we are talking about properties of real numbers. And with the properties of real numbers, I'm always more concerned with can you use and understand what is happening rather than can you always spit out the exact name all of the time. So you have to know the names, but again, try to focus on what is happening with those instead of just trying to memorize the names and maybe a formula for them. We should talk about. So the first property is the distributive property, and you've probably seen this throughout, but it just, if you have a number times a quantity that's being, added here, you can take A times the B and then add A times the C and you get the same value. Now notice here we just have the A and the parentheses flipped there. This is the more acceptable method, but you may on occasion see something written like this. And the same is true if you have subtraction. It will also, the distributive property works the same way. You just have to really be careful, especially if that A value happens to be negative. You want to watch as you're distributing those signs. So some vocabulary that we have, a term. So if you think about what a term is, a term could be a number, a variable, or it could be a number times a variable. And notice here we can even have our variable can have an exponent, and that is still a term. Okay, so we've got, when we say constant, constant is just a number, like 8 plus 8, that's adding a constant. Whereas a coefficient is the number that is multiplied by the variable. So here, the coefficient of 3m is 3. 3 is the coefficient in that term. Like terms have the same variables raised to the same power. So something like 3x squared and 4x squared are like terms because they have the same variables and the variables are taken to the same powers. To combine like terms, so if we had those, we could add 4x squared plus 3x squared, okay? And we end up getting 4 plus 3 and then times that x squared, which would give us 7x squared. So those are, when we talk about combining like terms, that's what we're looking at there. The letters have to be the same and they have to be the same power in order to add them. If they weren't, then you couldn't do anything and you just have to leave it. So properties of our real numbers. So the first thing, and we're only dealing with real numbers here, not those imaginary numbers, because our properties don't work necessarily the same. So we have the commutative property, and that just basically tells us we can add in any order. So A plus B is the same as B plus A, or 3 plus 2 is going to give us the same as 2 plus 3. The commutative property of multiplication tells us we can multiply in any order. So 3 times 2 is the same as 2 times 3. We still get 6 no matter what. Now think about why we don't have commutative properties of subtraction or multiplication or division, subtraction or division. Think about that. Never know when that might pop up. And then we've got an associative property. And I always think of the associative property. The associative property usually deals with 3 things. So associative property deals with 3 things, and that just tells us that if we have 3 numbers that we're adding, we can add them in any order, and we'll still get the same. They will be equal, okay? And we also have an associative property of multiplication, which again tells us that we can multiply our 3 numbers, so A times B, and then multiply it by C, or we could take B times C first and then multiply it by A, and we're still going to get the same value. Now, again, we have these associative properties of addition and multiplication, but we don't have them for subtraction and division. Think about why, okay? Order does matter in certain cases. And then we've got our identity properties, and those just tell us that we can multiply or add. When we add 0, we still get that same thing. You can take any number you want. The bank's not going to get mad if you add 0 to your bank account, nor is the bank going to get mad at you if you multiply your bank account by 1. You're still going to have those same values. So those are your identity properties. Again, they just give you that same identical value. They really don't do anything. Then we've got our inverse properties, and our inverse properties tell us, the inverse property of addition tells us that we can add a number and its opposite, so like 5 plus -5, and guess what we get? We get 0. Or our inverse property of multiplication tells us that we can multiply a number times its reciprocal, and we get 1 there. Okay, so those inverse properties are going to give us 0 or 1, depending on multiplication or addition, or yes, multiplication or addition. Symmetric property, this is kind of a fancy word. We don't use it a lot, but the symmetric property just tells us that if we have A equal to B, we could also say B equals to A. Yes, again, we need that property, and we use that property a little bit down the road in geometry, especially when we're trying to do proofs. We will use this symmetric property throughout and go from there. Then again, there's a copy of the distributive property. So, and then we have the multiplicative property of 0, which just tells us if we multiply any number, and notice this is real number, by 0, we get 0. And then if we multiply by -1, we get the opposite. So anytime we multiply by -1, we get the value's opposite. Okay, so that's just a real quick overview of your properties. Again, as always, if you have questions, please don't hesitate to ask. And I look forward to our class discussion and conversations.